So this is Mr. Huff, and let's go through some ideas about propulsion. And actually, we're taking a step way back. We're actually going to look at Newton's third law first, which states that for every action force, there is an equal and opposite reaction force. So if we have this airplane and it's flying along at a constant velocity, we know that the thrust of the airplane is equal to the drag, and that's only if it's at a constant velocity. This is Newton's third law, so it's that idea of balance. So we might have this plane flying at 60 meters per second, and it has a certain amount of thrust going forward. That means if the velocity is constant, then the drag pulling against the plane is equal to the thrust. And the same with lift and weight. So if you have the airplane flying at a constant altitude, the lift being produced by the flight surfaces is equal and opposite to the weight of the plane. And this is if it's not accelerating. So we could have so if it has a constant altitude, that would be true. If it has a constant velocity going left and right or up and down, then that would also be true. So that's Newton's third law. Another idea we need to understand is the idea of conservation of momentum. Let's start with the idea of momentum. The best way I've seen it explained is think about momentum as a unit of movement. So in this case, we have a mass and a velocity, and the product of those two is momentum, and they use a lowercase p to represent momentum. I don't know why. I have some guesses, but I don't know why they use a p for that. Just that's how we do it in physics. But the unit for momentum is really easy. It's the kilograms times meters per second. So notice this. If you have no velocity, you have zero momentum. So if velocity is zero, then momentum is zero, regardless of how much mass you have. All right? So from this idea, the idea of conservation of momentum is this. If you have a certain amount of momentum to start with, you're going to have the same amount at the end. So another way of stating that is mass times change in velocity. Let me zoom in a little bit here. Okay, so mass 1 times the change in velocity 1 plus mass 2 times the change in velocity 2 is going to have a net value of 0. So the changes in velocity in the system will cause a net change of 0 momentum. Okay, let's rearrange this formula a little bit. So if we move m2 delta v2 to the other side, we get m1 delta v1 equals negative m2 delta v2. All right. And then we can take this a step further and say if the initial velocity of both objects is 0, then we can say this, that the momentum of object 1 is equal to the negative momentum of object 2. So where you'll see this is in the case of two carts, and in the notes I have you do this simulation, but we have two little cars here next to each other, and we put a firecracker in between them, and we light the firecracker, so this applies an equal force on both vehicles. One goes backwards. Anytime we see the word backwards, let's say that is the negative value, and will be object 2. And anytime it's forward or a positive velocity, that's going to be object 1, and it will have a positive velocity. This will help us do our calculations in this scenario. I'm giving you a very specific scenario just like this to do problems with. So that's what we're going to say is this is number 2, and this will be number 1, because 1 is going positive, 2 is going negative. So backward is going to be negative, okay? We might also have this with a cannonball problem. We're going to say the cannon moves backwards and the cannonball moves forwards. So the cannon is object 2 and the cannonball is object 1, okay? Well, we might also have a rocket. Oh, didn't finish my arrow here. We might also have a rocket. The exhaust gases are going to be going backwards from the rocket or away from the rocket. Let's get the whole thing here. So we're going to say this is object 2, Let me get my purple. Okay, object 2, and the rocket is going to be object 1. All right, which means the velocity 2 is going to be our negative value, and our velocity 1 is positive. So if you keep that straight when you're doing these problems, draw pictures, it helps. But if you keep that straight, then you'll have no problem solving these very limited problems. So we're going to be using this formula because our initial velocities, all our initial velocities are going to be 0 meters per second. So we're saying it's stationary. And if that's true, then we can use this formula. Something I want to point out, if you have a negative velocity and you have minus or a negative mass 2 times velocity 2, and velocity 2 is negative, those negatives cancel out, okay? So the negatives will cancel, okay? If the negatives cancel, then we can keep in mind that whenever we're dealing with mass 2, velocity 2, that net result is going to be positive. So, but you can rearrange this. V1, to solve for V1, it's going to be negative mass 2 times V2, which is also going to be negative. So those two cancel out to be a positive number divided by mass 1. And the same to find mass 1, it's negative mass 2 times velocity 2, which in the problem will be negative because we picked the one going backwards, divided by the velocity 1, which is positive. So this equals a positive number here. And that means we're probably doing these correctly. Or you could do the time-honored just switch. So let's look at a practice problem here. We have cart 2, which is going to go, or this green cart is going to be cart 2 because it's going to go backwards, and this will be cart 1 because it's going to go forwards. So for mass 2, it's 4 kilograms, and our velocity is going to be minus 5 meters per second. And then for mass 1, that cart is going to be 2 kilograms. So we want to know how fast is that going, okay? So if we go look at this formula, mass 1 times velocity 1 equals minus mass 2 times velocity 2. And we go in and plug in the numbers that we know. Mass 1 is 2, velocity 1 we don't know. And that's going to be equal to minus 4, which is our negative value for m, times minus 5, our negative value for V2. Those negatives cancel out. So we get 2 times V1 equals 20, and that means V1 is equal to 20 divided by 2, and you get 10 meters per second. Notice this. If you put 4 times negative 5, you get a minus 20. And then here, if you get 2 times 10, then you get 20. So we have 20 and a minus 20. Those two are equal and opposite, so they would cancel out. We have conserved momentum. I'm going to recommend for these problems, use this strategy where you start with what you know and your formula, and you just plug in the numbers and do it as a simple algebra problem. That's going to be a lot easier, I think, for keeping track of your negatives than it will be to use algebra. But you do what you're comfortable with. All right, that's enough for now. Thank you for watching.